This video is a tutorial on using a Razer mouse to power a 16-foot LED strip. It was inspired from a video by Ani and the link for it is in the description. And a huge shout out to my friend Sam for helping me on the project and providing some of the parts for it. And before we get started, the wiring diagram for this project is going to be in the description as well. Since I already pre-built all this, I'm going to have you reference it throughout the video and in your build. So to start off with what this project does, we're going to take a Razer mouse and then tap into the RGB light signals, whether it's on the mouse wheel or the logo on the mouse. And we're going to reroute those signals to the 16-foot LED strip. And basically what happens in hindsight is the Razer Synapse program thinks it's sending signals to the Razer mouse, but in reality it's just lighting up our LED strip. The three major inputs that you need to note are going to be your USB for the mouse, the 16-foot LED strip, and then your 12-volt power supply, and the 12-volt power supplies will come with an LED strip when you buy it. So a quick note, when you're deconstructing the board, the only piece you need is this motherboard right here. All the other parts, the mouse wheel and the laser and all the other external plastic, you can just get rid of, because basically the main thing we need is access to the LED signals that go to usually the wheel and the logo. So moving on to the Razer motherboard, the only things we need to do with this are make sure to keep the USB cable that came with it, because we're going to have to feed that into whatever enclosure you want to use and tap that in there. And then you just need to tap into one of the RGB lights that are in there. I chose the wheel. Might be hard to see, but I chose the wheel. And once you do that and solder the RGB light to your Perf board, then you're pretty much all set with the mouse motherboard and what you need to do there. Alright, so pretty much for describing the Perf board, you can reference the wiring diagram to see where all the connections go and the pinouts, and I also put the data sheets for the transistors and the opto isolators, and I also put in the description what size capacitors you need and what two resistor sizes you need as well. So pretty much it works like the signals coming from the motherboard are going to go to the diodes of the opto isolators. So that way we can use the 3.3 volt logic that the motherboard's going to use to control the 12 volts for the LED strip lights for each RG and B signal. And then the resistors and capacitors there are used to help the circuit more efficient and help a little bit with current control. And then obviously the last major thing in the board is going to be the power coming from your 12 volt power supply. So once you've built the Perf board, I recommend putting this all into an enclosure. I used a Cantex box for mine, which you can get at a local hardware store. And then you're going to want to cut holes for the inputs and outputs of each of the three parts that I explained earlier. And then you're also going to want to see the note in the description where I talk about how when I tested this, I only tested it on the Windows 10 operating system, because that's what I currently use and what it currently works on. I don't know if it works for Linux or Mac at the moment. So if you have tried that and it works, let me know. That'd be great to see. Alright, so this will be the demo to prove that it works. As you can see, we got everything wired up here with our three inputs. And then if we go over here to the Synapse program, it thinks it's a depth adder. And it's right now it's spectrum cycling, but if we switch it over to static and then put it on blue, see it'll cycle over to blue. And then if we go to red and apply to all, you'll see everything switch over to red. So as you see, it's a wonderful integration. It works really, really well. I've been using it for a while now. And it also works for all of Razer's game integration systems. So like if you play Overwatch, it'll all the lighting effects for that game will integrate with the LED strip, or technically it'll integrate to the depth adder, but whatever effects it's sending to the depth adder will send to the LED strip. This concludes the tutorial on using a Razer mouse to power a 16-foot LED strip. I hope you guys are all successful in making your own. Let me know if there are any improvements that you make. It'd be cool to see what everyone comes up with. I know me personally, I will be using adjustable LED strip and a Razer Firefly to try and integrate all the LEDs that are in the Firefly to different points in the LED strip. So I hope you guys are the best, and thank you for watching.